Hello, today we're going to talk about how to use the pybind11 library to bind C++ code to Python. And this is great if you have existing C++ code that you want to use in Python, or if you have code in Python and you want to port it to C++ for performance but still use it for Python, or if you have code you want to use both in C++ and Python and you want to synchronize so that they use the same algorithms and the same backend but have two different interfaces. So this is something that I've used and I really like. It's very flexible. You can have object-oriented code and a lot of very handy C++ features and be able to use them, use the analogs in Python pretty relatively easily. So the pybind11 documentation has some examples. The one we're going to look at is the one that uses the CMake build system. I prefer this to the setup.py way of building the project because CMake allows you to be very flexible with how you build your C++ project, and then you can do whatever you want with it on the C++ side. Besides building the pybind11 bindings, you can build in automated tests, you can deploy it as a C++ library as well as a Python package. So this is where I would recommend starting out. So this link will take you to this GitHub repository where they have things set up with an example. And so we're going to need to clone this. It has a lot of miscellaneous files for portability on different operating systems, but I'll show you the minimum ones that you need for Linux. And then it has this pybind11 library as a Git submodule. So there's a separate GitHub repo for the pybind11 C++ library. And this is a header-only library. So if we go to our terminal, the first thing we can do is to clone this. And so now we have that here. And instead of building off of it, I'm just going to start a project in a separate folder. So I'll call that, facile example. And what we're going to need, the minimum that we need from here, we're going to need the CMake list.txt file to tell us how to build it. We're going to need the source file, which has the bindings. The only thing in there is this, I'll call it a binder file, and this has the interface with pybind11. And when we build our Python module, we're going to need setup.py. So if I oh, right. And before we look at the binder file, I'm also going to clone the pybind11 project into here. So there are different ways you could use it as a dependency. The simplest way is to just have the project folder in your directory, then use add subdirectory in CMake, and you can track it as a Git submodule or install it somewhere else and use find package. But this is the simplest way to get it started. So here in our folder we have the pybind11 dependency. So first let's look at the main.cpp file, which I don't think is a great name because this isn't an executable. It doesn't have an int main function, but that's what they decided to name it. We'll rename it just for our satisfaction. So here in their example, this is very minimal, so it doesn't have C++ code from anywhere else. This is all in one file. So you could imagine if you had a complex library, you wouldn't want to put everything in one CPP file. So I'll show you how to modify the CMake.txt file to allow you to link this to another library you have. But they just define one function, add, and then in here we include the header file from the pybind11 library, and has some macros. So this pybind11 module, this will create a Python module, and the name of the module is CMake example. So in Python, when you import this, you would say import CMake example. And that's important because the name of the Python module has to be the same here as it is in the CMake list.txt file when you build the target. I'll go through this in more detail, but this has to be the same as what's in this CPP file here. And then, so in this Python module, it just has two functions. Here, we're defining a function in Python that's called add, and then since we have an existing function, just giving it a function pointer. But you can also do a lot more complicated things in here. So like here, they're adding a second function called subtract, and that's defined by a lambda. So it's very nice what you can do here, and you can, like the names don't have to be the same between C++ and Python. And you can also include classes and all sorts of other stuff. Here, this is a little, this is something a little extra they're doing. They're using compiler definitions to set the dunder version. Let's make this simpler and just call this 0.0.1. And I'm also going to eliminate this compile definitions here because that's just, that's a little more complicated than I want to get into. So the first thing I'm going to do here, oh yeah, and then let's talk about the CMake list.txt. So it's very simple. So set the CMake version and then name our project. But this add subdirectory, this is going to include the CMake list.txt file from the pybind11 library, and that will define this CMake function pybind11 add module. And the documentation tells you to that this is a wrapper around add library. So you should think about it as add library in CMake, because this CMake example is going to produce a shared object SO file when we compile it, and it really is a dynamically linked library. So that SO file is going to be end up in the site packages folder of the Python virtual environment that you install it in. So just think of it as an SO file. So this target you can take and you can link it to other library dependencies, but just make sure that whatever you link it to will end up downstream. So I'll show you how to link it to a static library, because if you link it to something dynamic, then depending on where that Python module ends up, you might not still be linking the dependency. So first thing I want to do is rename this main function. So I'm going to rename it from main to binder.cpp, and then update the CMake list.txt file. This is going to be binder.cpp. And then the other thing I want to do is take this source code, and instead of defining everything in this one file, I want to make a library, a C++ library. So I'm going to make a, we'll call it mymath.cpp and mymath.hpp. We'll make these functions and these files, and then we'll put the source code there. So I'll put the the declaration in this header file, and then the definition I'll put in the CPP file. So include mymath.hpp, and that should be what we need there. And then in the binder.cpp, we need to now include not only pybind11, but include mymath.hpp to get that definition. So that'll pick up this header file and define the add function, but we also need to link this library. So first we need to create the library. So I'm going to use add library, and I'll call this library mymath. I'll make it static so that when we include in the pybind11 the shared object file, it kind of gets put in that binary, and we don't have to worry about losing the dynamic linking. And that has one source file there. And then on Linux, whenever you create in order to include this in an executable or a dynamic library on Linux, you always have to set target properties and take that target, and the property I'm going to set is position independent code. Set that to on. And so this will create a .a file from mymath.cpp, and then in order for that to be linked to this, so we've created our shared object file here, and we need to add another line to link the library, target link, libraries, CMake example, private, because nothing downstream of this is going to need to see the dependency. So the advantage of modifying the CMake list file like this is that now if you want to take, let's imagine that this library were something very large, that mymath had like a bunch of files and a bunch of different functions. You might want to do things other than just bind it to Python. So instead of listing out all your source files here and just making a shared object, making this directly, by making a separate library for this, you can do things like could deploy mymath as C++ library. So we could ship headers and .a file and then use that somewhere else. We could also create executable for unit testing. We could also create a separate executable if you have some utilities you want. So this gives you a lot more flexibility. Executable. So we're not doing anything in Python yet, but now that we have this, let's show how to build it. So if we create a build folder and run CMake, hopefully everything's correct. And now I have two targets I can make. I can make mymath to make the .a file, and I can also make this CMake example target. So first let's make mymath, and that should just be, so lib mymath.a, we made a static library. And then if we do make CMake example, then this is going to now create the Python module. And what that looks like is an SO file. So this SO file here, this will end up in the site packages folder of where we install it. So to show that, if we come up another level, now we have to run the setup.py. And the setup.py is going to call CMake. So this is pretty long, and it is, has a bunch of cases for different operating systems. I don't understand every line here, but the important part is it's going to call CMake at some point. So I'd recommend when you're modifying your C++ code to always run CMake manually before you try using the setup.py, because if the CMake fails, then you're going to get some error that looks like, hey, or my subprocess call to CMake failed, and then it'll give you some traceback. And that's a lot easier to deal with if you just run CMake outside of this, and then you can see all the error messages, the compiler errors, or possibly an error in your CMake file. So make sure it works outside of setup.py before you start dealing with setup.py. And then here we have everything you would have to build a Python package. So here, this CMake example, this is the name of the Python module. So this has to be the same as the target here, which has to be the same as the module that we declare in our binder file. But this this name here, this is going to be the name of like the wheel file. So when you say pip install this name, this can be different. But this is going to be the name of the shared object file, so that when you say import CMake example, it will go and find CMake example dot whatever dot so. So let's create the wheel file. So if I do python setup.py bdist wheel, then what's happening here? I think I just didn't save the file. Okay, I think it's just an issue that the Python on my system was Python 2, so you have to do this with Python 3, and I think 3.7 and above has worked for me. Okay, so now it's calling CMake, and it made all the targets, and then now this has produced the wheel file. So this is the wheel file that gets made, CMake example, or whatever the name of our package was in setup.py dot da 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 da, and then our shared object is compressed in there somewhere. And so now we can test this. So let me make a folder, and we can do make a virtual environment. Okay, well, I called it .venv. Didn't mean to do that. Just .venv is fine. And now let's use pip install and then find our wheel file, so dist wheel. And so now if we go into the .venv libs lib python site packages, we see that pip has put this SO file in here. So when our Python executable runs and we import this, it will come here and says, okay, CMake file that whatever. So this is a Python module. It's basically the equivalent of if you would have a folder with a dunder init file in it, a folder named the name of the module with a dunder init in it. So this is kind of the compiled C version of that, of what a pure Python package would be. So now if I run this Python executable, I should be able to import CMake example and run those two functions that we defined. So let's add 4 to 5. Great. And if we use subtract, then subtract, get -1. So we've successfully built and imported this. And just a quick note is that it does some type checking. So if we define these to take 2 ints. If I don't put ints in there, it'll say, hey, I expected ints. So you get some nice type checking here that you don't usually in Python. And there's a lot of other nice benefits as well. If you have objects in here, they're going to be more static than the general Python objects, so they'll take less memory. And anything you do in C++ is going to be faster than the equivalent in Python. So this repository that they've provided here is a great place to start, and take whatever other files you need, but the setup.py, the CMake list.txt, and the binder file are the bare minimum that you need. So I hope this helps you get started. Thank you.